Today, we will look at physics. We discuss physics today. I believe it's going to be a thing of joy to study this physical science, physics, today. The topic we're going to look at today is elasticity. Elasticity. Molecules of solid matter, the molecules of solid matter are closely packed. They are closely packed. And because of this now, the intermolecular force that hold these particles together do not allow them to be easily compressed, or stretched. Because of the intermolecular force that holds the particles of solid together, they are always close to each other. The particles are always close to each other. This is the factor that makes them to have a particular shape. So, if there is even a force applied on this solid matter, when the force is released, this solid matter always tends to maintain their size and their shape. When the intermolecular force, because of the intermolecular force that holds these particles of solid together, the solid particles or the solid object do not translate. They don't move from one point to another. So you can see this material, it extends, but if I leave it, it comes back to its original size, original shape. Because of the intermolecular force that holds these particles of this rubber together, it always likes to bring it back to its original size, original shape. This is another object again. This is rubber band. If I extend it, it extends. If I apply force on it, it extends. If I raise my hand now, the force is no more there. It retains its original size. It retains its original shape. This is called a spiral spring. If I apply force on it, if I extend it, it keeps on increasing. If I leave it, it goes back. It is that intermolecular force that helps to retain the shape and the size of these materials. Any material that when you apply force on it, or load on it, and that object can still retain its size or its shape when the force is released, is said to be elastic material. Elastic material. Elastic material is any material that when force is applied on it and the force released, the object has the potential to maintain its size and its shape. So this is also an elastic material. If I apply force on it and I leave it, it goes back to its shape. It's also elastic material. This is also elastic material. If I apply force on it, if I leave it, it goes back to its original size. This idea of applying force and retaining its size and its shape was explained by a scientist, Robert Hooke. Robert Hooke was the scientist that explained this elasticity. Elasticity is the property of this elastic material that helps it to regain or retain its size and its shape when force is applied on it. According to this man called Robert Hooke, he says that the load or the force applied on an elastic material is proportional to increases to the increase in length, the extension of that material. So according to Robert Hooke, there is proportionality between the force and the extension. The force and the extension. What is extension? Extension is the increase in length. This is the original length. Original length of this is like this. But if I increase it now by adding load, the more I add load on it, the more it extends. Let's look at the constant here. The F here is now equal to Ke according to the Hooke's law. This K is described as the elastic constant. Elastic constant. Or you can call it the force constant. The force constant. Or you can call it the stiffness, the property stiffness of the wire. The stiffness. That's the mean of this K. So by mathematics now, we can still find the mean of this K when we have, therefore, if I divide through or divide both sides by E to make K the subject, I will have F over K is equals to E. So the increase in length can be gotten by F over K is equals to E. The proportionality between the force. Robert Hooke. Robert Hooke was the scientist that explained the relationship between the force applied on an elastic material and the increase in length. So, according to him, if the elastic limit of the elastic material is not exceeded, the applied force on the elastic material is proportional to extension. That is the increase in length. I said something here, elastic limit. Elastic limit. Elastic limit, from here, he's trying to give a limitation to the proportionality between the increase in length and the applied force. Because if I continue to apply force on this, continue to apply force on it, if I continue and I leave it for some time, we are going to reach a point where if I remove my hand or the force, that material cannot regain its size again. That particular point that if exceeded, that material cannot regain its length is what we call the elastic limit. Elastic limit. So every material has its own elastic limit. There's a limitation at a particular point that if there is more increase in the load or force on an elastic material, that material will not regain its size and shape again. It becomes deformed. We are going to continue in our next class. In our next class, we are going to explain more on this elastic limit. We explain on what we call yielding point, and what we call plasticity, and then what we call the breaking point. Thank you very much. Make sure you share. Make sure you drop your comment. Make sure you like and follow. Thank you very much. Okay.